Yes.
Dragon.
He's overcome. Okay. You have in front of you the unit circle. This is the most important thing you will learn this semester. Okay, I'm not trying to scare you. I'm just trying to be realistic. What we talk about today and the things that we're going to take away from today, we are going to use for the rest of the semester. Those of you who go to calculus, when I ask my calculus kids, hey, how important is the unit circle? Oh my goodness, you have to know the unit circle. Okay, it's just reality. Okay, let's talk about why it is called a unit circle. Okay, specifically, if I just talk about a unit as opposed to units, unit would imply how many? One. Okay, so our unit circle has radius of 1. Okay. So let's talk about that. If our radius is 1 and our center is here at 0, 0, then when we travel a radius 1, then our coordinate right here would be 0. Okay. Now, when we're talking about rotational angles, we haven't rotated any here. We're at 0 degrees, 0 radians. But when we rotate to 90 degrees, AKA pi over 2, if our radius is 1 and here's 0, 0, then we travel up to this coordinate, and what would it be?
0, 1.
0, 1. Where this is going? No? Okay. If we rotate over here to 180 degrees, okay, 180 degrees is the same as how many radians? 1 pi, okay? If we have a radius of 1 and this is our origin, then when we travel to the left along the radius, this coordinate is negative 1, 0. I'm boring some of you. Some of you have already labeled the next coordinate we're going to get to. Okay, down here, we at 270 degrees, AKA we converted this yesterday, 3 pi over 2. From the origin, if we travel along the radius, we would travel down to 0, negative 1. Then I want you to go ahead and mark down that one full rotation is 360 degrees, aka 2 pi. I realize that these are drawn terribly, but we're just gonna go with it, okay? You have some triangles sitting in front of you, okay? Every single triangle that is sitting on your table has hypotenuse 1. The hypotenuse length of 1. Why do you think that is? Because our radius is 1 on our unit circle, okay? That was on purpose. So every single triangle you have in front of you has a hypotenuse of 1. So just real quick, let's talk about how I labeled those triangles that are sitting in front of you. If we have a 45, 45, 90 triangle with a hypotenuse 1, we know that legs to hypotenuse, the hypotenuse is radical 2 times as big. So our sides would be divided by radical 2. But do we leave our fraction like that? No, we have to rationalize the radical 2 over 2. You are going to love that number, I promise you. Over here, if our 30, 60, 90 triangle has a hypotenuse of 1, we know our short leg is half as big, and our long leg is radical 3 times as big as that short leg. Okay, what I want you to do is I want you to get all 3 colors of triangle from that little baggie in front of you, and they should match these 2 up here. Like, get them out. Everybody needs 1 of each. Okay, you'll also notice that sitting in front of you, there are colors of markers or highlighters that match these 3 triangles. Crazy. So this is what I want you to do. We're going to start with the blue triangle. So get the blue triangle. And you and somebody at your table are going to have to share one of the blue markers. Okay. What I want you to do is, do you see how there's like 3 of these angles in each? Okay. We're going to highlight the middle one blue. Take turns. If you have your own colors that you want to use, feel free. Okay, so we're gonna take your blue triangle. Okay, when we put your blue triangle right here. What? Okay, so do you see my projector, how this circle looks more like an oval? Okay, so this angle right here is a 45-degree angle. And yesterday, this right here, 45-degree angle. Yesterday, we converted this to be a radian measure of, Katie was thinking hard, pi over 4. Eventually, you'll know that. This is your warning. Start remembering that. Okay. So here we go. When I put the triangle up here, what? No, it's just reality. When I put this triangle up here, how do we get to this coordinate? We go over X and up or down Y, horizontally and then vertically. So put your triangle right there, like physically put your triangle on your paper, where 1, the hypotenuse is along the radius. So the 45-degree angle is right here at the origin. There we go. So what do? We go right along this side, has a length radical 2 over 2. We go up along this side, it has a length of radical 2 over 2. So our coordinate, we went right radical 2 over 2, we went up radical 2 over 2 along our triangle. Our 30, 60, or our 45, 45, 90 triangle gave us those lengths. Cool. Okay. So now, if I put my triangle right here, all right, it looks like I am 45 degrees away from 180. How many degrees would that be? 180 minus 45. 135. Okay, so if you're trying to remember these angles, okay, this guy's 45 away from 180, okay? Okay, so let's go to radians. We are pi over 4 away from pi. So 1 pi, subtract pi over 4. We're at 3 pi over 4. Okay, so now what happens when we put our triangle up here with 1, our hypotenuse along the radius, because that's our distance. Okay? It looks like we need to move left along this side of radical 2 over 2 and up along this side of radical 2 over 2. So our coordinate, we moved left radical 2 over 2 and up radical 2 over 2. So our x coordinate is negative because we have to move left. That's non some of you. Okay. Okay, next, let's go to the third quadrant. If I put my triangle in here with 1 along the radius, we are 45 degrees past 180. That measure would be 215 degrees. Okay, flip our brains to radians. This measure is pi over 4. You'll hear that? Okay, pi over 4. We are pi over 4 past 1 pi. It's not 215? Oh, so you guys are paying attention. Oh. I did that on purpose. You guys aren't like, you guys are helping me out here. Come on, I need you. Sometimes Mrs. Holman makes mistakes. Owen, be confident. You got this. Okay, so now we're pi over 4 past pi. These are actually the easy ones. 5 pi over 4. Okay. So now if we put our triangle here, it looks like we're going left radical 2 over 2 along that side, down radical 2 over 2. All right. So our coordinate is negative radical 2 over 2, negative radical 2 over 2. All right, last one. Now we are 45 degrees away from 360. What angle is that? 315. See, I knew you guys. Okay. Flip to radians. We are pi over 4 away from 2 pi. 7 pi over 4. Okay. And if we use this triangle, we're going to go right radical 2 over 2 and then down radical 2 over 2. So this is nice. I have 4 coordinates with radical 2 over 2s. We just like change some negatives and positives, right? What's true about all of the radian measures for those four angles. They all have something pi over 4. That's nice. How far away are all of these angles from the x-axis? They are all 45 degrees away. They are all pi over 4 radians away. It is amazing that we have this symmetry, isn't it? You guys are like, it's really not that cool. Just wait. It will be very helpful here. Okay. All right. Now, what do you notice about your pink and green triangles? They're the same. Okay. I just want to color code things different up here. So what I'm going to have you do is we're going to go to pink. And I want, I think it was, doesn't matter, we'll make it up. I want these angles here to be pink. So they are closest to the x-axis. All right, are we good with our pink? All right, so we're going to take our pink triangle. Remember, 1, our hypotenuse, sits on the radius. So here we have a 30-degree angle, which is the same as pi over 6. So here we go. If we set this on our unit circle and we travel to this coordinate, it looks like we're going to go right, radical 3 over 2, and up this distance of 1/2. You know what I really like? So far, all of our fractions for these coordinates are over 2. I like that. Okay. Over here, in the second quadrant, if we are 30 degrees away from the x-axis, 30 degrees away from 180 would mean we have a measure of 150. And what about pi over 6 away from pi? Pi over 6, right? All right. So if we put our triangle here in the second quadrant, it looks like we're going to have to travel left the distance of radical 3 over 2 and then up the distance of 1/2 to get to this coordinate. So we are negative radical 3 over 2, comma, positive 1/2. Some of you have started to work ahead because you know where this is going. Okay. I'm not upset about that. Okay. What? No, I'm not. I actually think it's kind of wonderful if you figured out the pattern, okay? I'm gonna keep going slow just so we can make as many connections as we can. What? Okay. 30 degrees past 180 would be 210 degrees. Pi over 6 past pi, 7 pi over 6. Now, I want you to listen to how I'm saying this. Like, these are things that can be helpful to you when next week I ask you to fill a blank one out from scratch. Okay. All right. So if I have my triangle here, we're going to go left radical 3 over 2 and down 1/2 to get there. So left radical 3 over 2 and down 1/2. Okay, so then 30 degrees away from 360 would be 330. Pi over 6 away from 2 pi would be 11 pi over 6. And then we're going to have to travel right radical 3 over 2, down 1/2. Okay, let's make some observations. Every single peak angle. Why did I do mine in red? I'm sorry. I should have done mine in pink. Every single pink angle. Do you notice how we have radical 3 over 2, 1/2? Radical 3 over 2, 1/2. Radical 3 over 2, 1/2. Radical 3 over 2, 1/2. We just have different negative signs and positive signs. Do you notice that? Oh, that's so great. All of these angles are 30 degrees away from the x-axis. All of these angles are pi over 6 away from the x-axis. And all of those radian measures are something pi over 6. Okay, what do you think I'm going to ask you to do next? Let's highlight some green. I am just digging the symmetry that we're creating here. I'm hoping that you are also noticing the symmetry we've got going on here. I could, yeah. Okay. Now, remember, our pink and green triangles are the same. All right. I just color coded them to help us visually up here. Okay. Are we good? This is not helpful. That was not helpful. Why would you throw? Okay. So we're going to talk about 60 degrees, which is the same as pi over 3. I really love that 60 degrees matches up with pi over 3 and 30 degrees matches up with pi over 6. I think that's cool. Okay. Now, if we put our green triangle up here where the hypotenuse is our radius, then we go right along the side of 1/2 and up along the side of radical 3 over 2. Over here, if we are 60 degrees away from the x-axis, notice how I'm always going towards the x-axis. I really don't care about the y-axis, okay? 60 degrees away from the x-axis. 60 degrees away from 180. 120. Pi over 3 away from pi. 2 pi over 3. Once again, these numbers should be familiar, especially from yesterday, right? These are all the ones that I had you convert. So if we go left 1/2 and then up radical 3 over 2, then our coordinate is negative 1/2 positive radical 3 over 2. In the third quadrant, we are 60 degrees past 180, which means we're at 2. Thank you. Pi over 3 past pi gives us 4 pi over 3. And we are going to go left 1/2 and down radical 3 over 2 along our triangle. Okay? All right, ditch the triangle. We know what's going to happen next, right? 60 degrees away from 360. That's an easy one, 300. Pi over 3 away from 2 pi. 5 pi over 3. And we are going to go right 1/2 and down radical 3 over 2. I think it is so great that every single green coordinate that we have written has an x of a positive or negative 1/2 and a y of a positive or negative radical 3 over 2. They are all 60 degrees away from the x-axis. They are all pi over 3 radians away from the x-axis. Okay, are you seeing the symmetry that I'm seeing? Okay, that's why I had you highlight, so it really pops out at you. Okay, let's make some other observations. What do you notice between the coordinate at 30 and 60? What happens, Rex? They flip. So radical 3 over 2, 1/2. This one's 1/2 radical 3 over 2. Okay, you have like 3 numbers to remember, and then you just have to figure out where they go. Okay, so if I'm you, and on Monday when I give you a unit circle quiz, if I'm filling this out, I would fill out all of the quadrantal angles first. Those are the ones on the x-axis. Then I would fill out all of my 45-degree angles. I would fill those all at the same time. I would fill out the 30 degrees all at the same time. And really, if you know the first quadrant, then it reflects to the second quadrant. That reflects to the third quadrant. That reflects to the fourth quadrant. Do you see that? So as long as you know these 3 coordinates right here, boom, 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 you know them all. Okay. Now, how does this help us? Okay, well, let me tell you. Look at your triangle. Okay, we talked about yesterday how our sine ratio is opposite over hypotenuse. We talked about how our cosine ratio is adjacent over hypotenuse. Well, when our hypotenuse is 1, when we divide by 1, we don't actually write it, right? So the adjacent over 1, the opposite over 1 is just that number. Okay, so in the unit circle, trying to find a color that's going to stand out. Okay. Our x, y coordinates represent the cosine of the angle, comma, the sine of the angle. Only on the unit circle. This doesn't work with any other circle. The radius has to be 1. On the unit circle where our radius is 1, any coordinates that we can point out, the x coordinate is the cosine of the angle. The y coordinate is the sine of the angle. Okay. So what this means is without having to draw a triangle, without having to, draw a triangle and do the calculations, we know that the cosine of 135 degrees is negative radical 3 over 2. We know that the sine of pi is our y coordinate, 0. Okay. Now, okay, well, that helps us with sine and cosine. What about tangent? Well, the tangent of theta is going to be our y over x coordinate. Okay. This is how we use the unit circle. X, y, cosine, sine. Do you notice how both of those are in alphabetical order? X, comma, y, alphabetical order. Cosine, comma, sine, alphabetical order. That's how you can keep that straight. And then tangent is y over x. I am not sure how your Algebra 2 teacher taught this to you. STC. All students take calculus? Okay, that's how I like to teach it. Okay, let's talk about what it represents. Okay, of our 3 main trig functions, this is where this is who is positive. All of them are positive in the first quadrant. The sine is positive in the second quadrant. Well, look, all of our y coordinates are positive. The sine is positive. Okay, tangent is positive in the third quadrant. Well, do you notice how x and y are both negative? So when you take y divided by x, tangent's positive. All right. And then C, the cosine is positive in the fourth quadrant. All of our x coordinates are positive. Okay. Cosine's always positive. Okay. So what you're going to be asked to do is to use the unit circle to answer some questions about evaluating trig functions. Okay. So we're going to start with theta is 5 pi over 6. Now, for this weekend's homework, and if you want to do these on the back, you want to do them in your notebook, I don't care, but we're going to do some examples, okay, that I think would be good for you to write down. So I'm going to give you a moment to put all of your triangles in your baggie, and then either on the back or somewhere in your notebook, we're going to do a couple examples of how this goes. Okay. For this weekend, you're probably going to use the unit circle to help you because you're learning it. But eventually, this unit circle is going to be in your head to where you're just going to recall from memory those coordinates. Okay. So what we're going to do is we're going to figure out the sine, cosine, tangent ratios, as well as the cosecant, secant, and cotangent ratio. Oh my gosh, we only talked about sine, cosine, and tangent. Hey, it's okay. We know that these are reciprocals, okay? Okay, so let's go to our unit circle. At 5 pi over 6, our coordinate is negative radical 3 over 2, positive 1/2. Cosine, sine. So our cosine ratio is negative radical 3 over 2. Our sine ratio is a positive 1/2. Okay. Now, how do we evaluate tangent? For tangent, we take our y coordinate, sine, divided by our x coordinate, cosine. Okay. All right, well, what happens here? Okay, these 2's are going to cancel out, and we are going to be left with 1 over negative radical 3. Am I going to allow you to leave your expression like this? You need to rationalize to negative radical 3 over 3. Okay. Okay. So now let's talk about our reciprocals. Okay. If the sine is 1/2, then we know reciprocal, our secant, is 2 over 1. If we know that the cosine is negative radical 3 over 2, then the secant is the reciprocal, negative 2 over radical 3. But we can't leave it like that. We have to rationalize negative 2 radical 3 over 3. For cotangent, you can think of this a couple different ways. You can think of cotangent as x over y, because that's the reciprocal, or you can think of the tangent and flip that, okay? For right now, let's just think of it as x over y. Our x coordinate is negative radical 3 over 2. Our y coordinate is 1/2. Just like before, these 2's are going to cancel, and we're going to be left with negative radical 3 over 1. Okay. By knowing the unit circle, we are saving time by not having to draw a triangle. We just know those special relationships up here. Okay. Now, something else you might want to consider, okay, if I ask you to do this, well, if you know the coordinate at pi over 6, well, I know that the coordinate at pi over 6 is radical 3 over 2, 1/2. Okay. Since pi over 6 is in the second quadrant, well, I know that sine is going to be positive, the other 2 negative. And then you can just remember your first quadrant angle. Okay. So that's a possibility too. If you want to just think about the radical 3 over 2 and the 1/2, we know that we're in the second quadrant. So cosine and tangent should be negative. Okay. That's an option. All right. Let's talk about what happens when we're at a quadrantal angle. So we're going to look at theta is pi over 2. Okay. So at pi over 2, that's the same thing as 90 degrees. That means we moved up along the radius, and our coordinate is 0, 1. X comma y, 0, 1. So that means our cosine ratio is 0. Our sine ratio is 1. Okay. Our tangent ratio we get by taking y over x, sine over cosine. Oh, yikes. 1 divided by 0. Do we do that? No, this is undefined. Okay. Now, when we look at, I'm going to go in a weird order. When we look at the cotangent is x divided by y. So if we flip that, we have 0 over 1. Is that okay? Yeah, that's just 0. So the tangent is undefined at pi over 2, but the cotangent at pi over 2 is 0. Okay. All right. What is the reciprocal of 1? 1. But what's the reciprocal of 0? Undefined. The reciprocal 1 over 0 is undefined. All right, so in your homework, you are going to be asked to evaluate trig functions at these special angles. I will tell you right now, on Monday, when you come in, I'm going to give you a blank unit circle and you're going to fill it out. So make sure that Sunday evening, Monday morning, whatever, you look at this unit circle and you remind yourself. Me giving you a blank unit circle to see what you can do is going to happen multiple times. Okay. Okay, make sure that your triangles are safely in the middle for next class. All of the markers and highlighters are safely in the cup for next class.